Bismillahirrahmanirrahim. This is lecture number 12 and it is part 2 of our topic mensuration. In the last lecture, we have discussed different shapes of two-dimensional and three-dimensional figure, and the last figure was cone. Now the next figure of 3D shape is a sphere. And what is a sphere? Circles in 3 dimensions is known as a sphere. This is a curved surface of the sphere having no edge, and this is the radius of a sphere. Consider a sphere and a cylinder as shown. Now we are going to discuss about the surface area of sphere. So what is the surface area of a sphere? Let the radius of a sphere and the cylinder are same, and let the height of cylinder is such that the sphere can easily fit into the cylinder as shown. It can be seen that the height of cylinder is equal to the diameter of a sphere. It is proved by a mathematician, Archimedes, that the surface area of a sphere is equal to the curved surface area of cylinder. The curved surface area of cylinder is 2 pi r h. Therefore, the surface area of a sphere is 2 pi r h. But h is equal to 2r is the diameter of a sphere as shown. Therefore, surface area of a sphere is equal to 2 pi r bracket 2r. Therefore, surface area of a sphere is equal to 4 pi r square. We can say that surface area of a sphere is equal to 4 multiplied by area of circles. Now the volume of a sphere is equal to 4 upon 3 multiplied by pi r cube. Next 3D shape is hemisphere. Is half of a sphere. Therefore, volume is equal to half of volume of a sphere, and it is equal to 1 upon 2 bracket 4 upon 3 pi r cube is equal to 2 upon 3 pi r cube. And the surface area of hemisphere is equal to half of surface area of a sphere. And this is equal to 1 upon 2 4 pi r square, and it is equal to 2 pi r square. Surface area of closed hemisphere. Surface area of closed hemisphere means it is closed from the top. That is, area of top of circle is included. Therefore, it is equal to 2 pi r square area of hemisphere plus the area of top of the circle, that is pi r square. So it is equal to 3 pi r square. Next 3D shape is pyramid. There are different types of pyramid. The pyramid consists of its base and number of triangles. The type of pyramid depends upon the type of its base and the number of triangles depending upon the number of sides its base has. A square pyramid has its base as a square and the number of triangles are 4 because a square has 4 sides. A rectangular pyramid has its base as rectangle and the number of triangles are 4 because rectangle has 4 sides. Similarly, triangular pyramid consists of a triangle as its base and three triangles because triangle has three sides. A pentagonal pyramid has base as pentagon and it has five triangles. Let us discuss the square pyramid and then try to develop its formula of its volume, surface area and try to make its nets of solid. A square pyramid has its base as square as shown. Triangle T1 with its height represented by L. This height is known as slant height of pyramid, shown in figure. On its back, triangle T2 is shown having same height is equal to L as shown. Triangle 3 is shown on the left side of the pyramid and on its back triangle 4 is shown. The base is square. If we open the pyramid, then we can see the height of pyramid capital H is shown, which turns the pyramid into 3D shape. So the volume of pyramid is 1 upon 3 multiplied by base area multiplied by perpendicular height. Let S be the side of a square. So base area is equal to S into S is equal to S square. Capital H is the perpendicular height of pyramid. Therefore, volume of square pyramid is equal to 1 upon 3 multiplied by S square multiplied by H. Surface area of pyramid is equal to base area plus sum of area of triangles. Surface area of square pyramid is equal to area of square plus sum of areas of four triangles. This is equal to S square plus 4 bracket 1 upon 2 into S into L, where L is the height of triangle and it is also known as slant height of the pyramid. Therefore, general formula for pyramid are volume is equal to 1 upon 3 into base area into height. Surface area is equal to base area plus sum of area of triangles. Now working for nets of solid of pyramid. When we open the pyramid as shown, then here is the base in the middle. Triangle 1 is in front, triangle 2 is on its back, triangle 3 is on left and triangle 4 is on right. So this is the nets of solid of pyramid. Next 3D shape is prism. Here triangular prism is shown in figure. Number 1. There are two triangular bases, or in other words, two ends which are identical and parallel. If we take a triangle and place it on front end as shown and slide it towards the other end, then it shows that both ends are identical and parallel to each other. Number 2. It shows that rectangular faces of prism. Front rectangular face represented by R1. Triangle T2 is shown on the left side of prism. On the right side, triangle T1 is shown. Now rectangle R2 is shown on back and rectangle R3 is shown at the base of prism. So there are two triangles and three rectangles in triangular prism. So all its faces should be rectangles. There are many types of prism: triangular prism, square prism, rectangular prism, etc. Type of prism depends upon the type of its base, or we can say ends of prism. Now in triangular prism, same size of triangle is fit into the prism. Similarly, same size of a square is fit into the square prism, and so as in triangular prism. This shows that the two ends of each prism are identical and parallel. Further, these are the cross section of each prism. Here triangle has three sides. This implies that triangular prism has three rectangles. A square has four sides, so a square prism has four rectangles as shown. 1, 2, 3, and here is 4. Rectangle has four sides, so there are four rectangles. 1, 2, 3, and 4. Difference between pyramid and prism: two ends are same and parallel in prism as shown. On the other hand, two ends of pyramids are not same. It is decreasing as we go upward to the pyramid as shown. A square prism is shown in figure. Now volume of prism is equal to area of cross section. The square having area of cross section of a square prism is shown in figure. Multiply by cross sectional height. The sides of a square is denoted by S. This square is also the cross section of a square prism. Therefore volume is equal to S into S multiplied by cross sectional height is shown and denoted by L. Therefore the volume is equal to S into S into L. This is equal to S square into L. The surface area of a square prism is equal to surface area of two squares plus surface area of four rectangles. This is equal to 2 bracket S into S plus 4 bracket L into S. This is equal to 2S square plus 4L into S. Now the volume and surface area of triangular prism. The cross section is shown and the cross sectional height L is also shown. Therefore, volume is equal to area of cross section multiplied by cross sectional height. The triangle having sides A, B, and C is shown. Its perpendicular height is H. Therefore, area of cross section is equal to 1 upon 2 B into H. And cross sectional height multiplied by L. Now surface area is equal to 2 bracket area of cross section of triangles plus area of n rectangles, where n depends upon sides of base. Triangle has three sides, so there are three rectangles. Therefore surface area is equal to 2 bracket 1 upon 2 into B into H plus area of rectangle 1 having length is equal to L and width is equal to C, that is L into C, plus area of second rectangle having length is equal to L and width is equal to B, that is L into B. plus area of third rectangle having length is equal to L and width is equal to A, that is L into A. Therefore surface area is equal to B into H plus L into C plus L into B plus L into A. Now nets of solid of triangular prism. Here there are two triangles, that is bases of prism. When we open the triangular prism to turn into two dimension as shown, there is front rectangle is equal to R2, base rectangle R1 and back rectangle as R3. Triangle T1 is on right and triangle T2 is on left. Therefore the nets of solid is triangle T1 on right and triangle T2 on left. Base rectangle R1, front rectangle R2 and back rectangle R3. Nets of solid of square prism. Here square prism is shown, square on right side is shown, then square on the left side is shown, then rectangle in front is shown, and on the other hand rectangle on back is also shown. Then rectangle on top and bottom is shown. When we open the square prism, we can see its nets of solid. On the base rectangle there is a square on its right and the other square on its left. We can see the front rectangle and back rectangle, and then below the front rectangle there is a top rectangle. There are two squares as the base of square prism. Bottom or base rectangle, top rectangle, front rectangle and back rectangle. Right side is square and on the left is another square. So this is the nets of solid of square prism. The summary of formulas of 3D shape is made for your convenience. It is important to learn and remember all formulas in order to solve the questions of past papers as well as upcoming exams. The first shape is cube having all equal sides denoted by S. So volume is equal to base area multiplied by 3D height, which is equal to S into S into S is equal to S cube. Surface area is equal to 6S square as it has 6 faces. Perimeter equal to 12S. Next shape is cuboid. So its volume is equal to length into breadth into height, that is L into B into H. Surface area is equal to 2 bracket L into B plus 2 bracket B into H plus 2 bracket B into H. Its perimeter is equal to 4L plus 4B plus 4H. Since it has 4 lengths, 4 breadths and 4 heights. Next shape is cylinder having radius is equal to R and height is equal to H. It is open from top and bottom as shown. So volume is equal to pi r square H. And surface area is equal to 2 pi r H. For open cylinder, that is open from top and closed from bottom as shown, its volume is equal to pi r square H and surface area is equal to 2 pi r H plus pi r square. For closed cylinder, that is closed from top and bottom as shown, volume is equal to pi r square H and surface area is equal to 2 pi r square H plus 2 pi r square. Next shape is open cone, means it is open from bottom as shown. Its volume is equal to 1 upon 3 pi r square H and surface area is equal to pi r L, where L is slant height and H is perpendicular height. For closed cone means its bottom is closed is equal to 1 upon 3 pi r square H, and surface area is equal to pi r square L plus pi r square. It is closed from bottom, that is why pi r square is included. Next shape is a sphere. Its volume is equal to 4 upon 3 pi r cube, and surface area is equal to 4 pi r square. Next shape is open hemisphere, that is, it is open from top as shown. So its volume is equal to 2 upon 3 pi r cube, and surface area is equal to 2 pi r square. Closed hemisphere means its top is closed, therefore its volume is equal to 2 upon 3 pi r cube, and surface area is equal to 3 pi r square. Next shape is pyramid having 3D height or perpendicular height is equal to capital H. Therefore volume is equal to 1 upon 3 base area multiplied by capital H. Surface area is equal to base area plus sum of area of n triangles. N depends upon number of sides of base. Last shape is prism. Its volume is equal to area of cross section as shown multiplied by cross sectional height as shown. Surface area of prism is equal to 2 bracket area of cross section. There are two triangles as base of prism as shown plus sum of area of n rectangles as shown depending upon the type of base of prism. So this is the end of this lecture. So if you have any question, then please ask me in the comment section. I will respond it. Thank you very much, and Allah Hafiz.